Welcome to the viewers. We discuss today an important idea in complex analysis. Especially we prove a result. Very interesting result. Prove that del 2 del x2 plus del 2 del y2, this operator will be equals to 4 del square del z del z bar. How to prove this result? At first, for the part of proof, we know already x plus iy, that will be z. Therefore, x minus iy, that will be obviously z bar. Then we have, if we solve these two, x is equal to half of z plus z bar and y is equal to, if we adjusting these terms, minus of I by 2 z minus z bar, because this I will be adjustable, that's why it is minus of I by 2. In the that will be shifted from, I will be shifted from this denominator to numerator. That's why these things happen. And now we have to solve this. Del x del z, that is a partial derivative with respect to z, and suddenly it will be half of del z of z, that will be 1, and del x del z bar, that will also be half, and del y del z, and it's clear that it will be minus of I by 2, and del y del z bar, certainly it will be I by 2. Now we are using the chain rule. We have to follow del z using this operator, and it will be using by chain rule del x del z plus del y del z. Now substituting this value, that is del x and del x del z, that will be half, plus del y del z, and suddenly it will be minus of I by 2. So del y of, it will be minus of I by 2, and if we take in common these terms up, so the result will be del x, it is not operator, actually it is a dot terms, and we substituting these values, product value, it is not operator, that's operator, simply dotted term, so it will be minus of I into del y, and we find these terms. Similarly, del z bar, so it will be clear, that is del x into del x del z bar plus del y into del y del z bar, and certainly if we substituting these values, we are getting for the z bar terms, that is half and I by 2. So taking common half, similarly we obtain as del x plus I del y using these two terms, and finally we find the result del x dz and del z bar. Now we are going to the final result. Now del 2 del z del z bar, that will be del z of del z bar, and if we substituting these values, it will be 1 by 2 into 1 by 2, that is right externally, del x minus I del y, and that will operated to del x plus I del y, and 1 by 4 if del x is operated with del x plus I del y minus I by 4 del y, that will be operated to del x plus I del y, and if we break this bracket, we obtain here one by 4 del x is operated, that is we obtain here del 2 del x 2 plus I del 2 del x del y minus I by 4 del 2 del y del x plus I del 2 del y 2, and if we take in common 1 by 4 terms, finally we will find here del 2x del x2 plus I del square del x del y minus I del square, it will be changes as del x del y plus I square minus of I square is plus, that is del square del y 2, as del 2 del x del y is equal to del 2 del y del x, so it will be equal, and I will be there, simply cancelled. Partial derivative exists, and since these two are cancelled, so final terms will be half of del square del x2 plus del square del y2, and we are going to the final terms. So in this way we prove our results. If you like this video, like it, share it, don't forget to subscribe the channel. Thanks for watching.